All right. Hello, everybody. Welcome to another week of quarantine. So, today we're going to start our chapter on financial mathematics. This will be the second to last subject that we'll learn about this semester. I plan on doing financial maths with you for the next 4 lectures. That's 2 weeks. And then for the final 2 weeks of the semester, I plan on doing some graph theory, which I've been waiting on all semester. Yes, this will be the first of 4 installments on financial math. Today will be a shorter video. We'll just cover section 10.1, which talks about percentages, just getting used to percentages, how they work, what weird things can happen with them. I know that, they often feel like a pretty simple thing that everybody learns about percentages in elementary school, but we'll just talk about them again because it's good to know all of the basics, and there are some tricky things that you might not have thought about in elementary school. I've got a couple of good paradoxes concerning percentages. Good, so today we'll just do that. On Thursday, I will cover the 2 sections on interest. That's both simple interest and compound interest. Two very important things which will affect the rest of your life because everybody's charging you interest, and you won't be able to. Unless you're really good about saving money or buy a very cheap house or car, you will have to deal with loans at some point in your life and interest on that. Probably most of you are already experiencing loans and interest for your own studies. Okay, so today will be a brief overview of chapter 10 and talk about percentages. Tomorrow, or Thursday, will be simple and compound interest. And finally, next week, we'll talk about what you should be doing for your retirement savings and how debt affects people, and how you can effectively handle your debt, because it's true. I just read a statistic that more than 50% of Americans are under some kind of debt. I think it's something like around 66%. So this will be a good thing to talk about. All right, so let's start in on the notes. So, good. All right. So, this is March 31st, 2020. Today, begin chapter 10 on financial math. The overall goal here is not going to be to show you how to make you memorize formulas and do all of these things. The goal is just to provide some basic understanding of these concepts, because I think most people, including myself, because I frankly haven't put the time into figuring a lot of these things out. I think everybody knows that money rules the world around us. Whether you think that's fortunate or unfortunate is your own philosophical belief. But nobody can deny that we all have to deal with money. And a statistic that's in your book, now that we're talking about percentages, a statistic about 75% of Americans agree that they could use more advice or answers about their own finances. Agree they could use advice or answers about their own finances. I'm not just making this up entirely. It's in your book as from the 2015 Consumer Financial Literacy Survey. So these things are there. Oh, no, Retirement Security 2015, a survey done by the NIRS, the National Institute on Retirement Security. So these are real statistics. One of the things, however, that I will talk about is we should all be very careful about taking statistics for granted. A lot of the time, percentages are deceptive. So they often seem very simple, and we say, okay, well, we have this percent and this percent. We'll just multiply a couple things together, and we'll be done. But lots and lots of the statistics that you see on the internet have been miscalculated. So we'll talk about that a little bit today too. But the goal is to understand some fundamental concepts of finances. Not to not to get lost in formulas and equations. I'd like not to get lost. Having said that, we will do some calculations. This is a math class, but overall I'm just looking to inform you. Okay, so let's start this off. So section 10.1, percentages. Okay. These are a good example of how math topics can be deceptively simple. So when I say simple, I guess, yes. So I'll do a little, why don't I do a little caution sign? So, caution, paradoxes ahead. Okay. Well, let's start out with a definition, right? So a definition of a percentage. A fraction. So I know I'm using the word fraction in the definition of percentage, and well, that should hint at something. A fraction with a denominator of 100 can be interpreted as a percentage. The word percentage literally comes from literally per 100. So in other languages, I mean, so percent comes from the Latin for us. In other languages, they don't have the word percent. They just literally will say per 100. I know that in France, that's how they do it. They just talk about, well, if I have, instead of saying I received 50% of my pay last week, they would actually say I received 50 out of 100 of my pay last week. And maybe your pay wasn't $100. But the idea is to, find a common denominator. Here, a common denominator of 100, because this is this is what makes percentages nice to deal with. Literally per 100, because fractions. So, why don't I say? Fractions may be difficult to deal with if they don't have a common denominator. Here, since X percent is equal to x over 100, every percent has a common denominator. All I'm really trying to say is percentages are easy to compare rather than fractions. You might have a harder time comparing 7/8 and 15/16 than you would comparing 50% and 60%. It's easy to see that 50% is less than 60%. Slightly harder to see that 7/8 is less than 15/16, though not so. I mean, some people like to work with fractions. I personally do quite like to work with fractions. So, on one little note, this is kind of a fun fact. The percent symbol indicates the hidden denominator. So the percent symbol is actually supposed to look like a fraction, right? You have your numerator, denominator being 100, and this is your fraction. Good. So what are some applications of percentages? So what do we use them for? Because of this common denominator, we like to use them for comparisons. Comparisons. Common denominator makes comparing quantities easier. Okay. A second application of percentages is, when you deal with say, your taxes or tips or fees or something. So, dealing with taxes, tips, or fees. We'll do some examples using these. And finally, they can help us understand increase and decrease in quantities. Help us understand how quantities increase or decrease relative to a given baseline. Now, this word baseline is important. It is actually it's actually what gives a percentage its meaning, right? So if a percentage is just a fraction out of 100, well, on its own, that doesn't mean anything. If you just said, I'm 5%, someone would have a hard time understanding you, probably. They'd say, you're 5% of what? Are you 5% human? Are you 5% American? Are you 5% Native American? I don't know. So you have to give. So this baseline is important. Baseline is crucial. So need to know what you're taking a percentage of. So sometimes it's pretty implicit. So in an example that annoys a lot of mathematicians, if your baseball coach told you to give it 110%, the baseline is implicit. The statement is impossible, but the baseline is implicit. The baseline there is of your energy, right? So when your coach tells you to give it 100%, 110% of your energy, of your effort, is what we all understand that to mean. And of course, we only have 100% of our effort to give. That's not to say that percentages always have to be less than 100. You could have, 10 apples is 200% of 5 apples. You can talk about things like that. It's just that generally we do use percentages as smaller than 100. And in that case, you certainly don't have more than 100% of your effort to give. Okay. %110 of what? Okay. So this is the point where I give you a cautionary note. So here's my little caution symbol. Especially at times like these, when we have so many crazy things going on, we like to find figures to reassure ourselves. But we should be really careful about which figures we listen to, because not everybody figures these things out right. So I'm just going to put a note. I know this is a bit philosophical rather than just a math topic, but in times like these, everybody likes figures, percentages. Be careful what you listen to. I just find that almost every time I see a figure online, there's a flaw in it. Mathematicians are not perfect. Are not perfect, and most statistics / percentages I see online are flawed, especially with regards to corona. I mean, especially one of those big things is that people love to find... I mean, you have to be careful about data before a thing's finished, right? So already people love to give statistics about COVID-19 without anybody having all the data yet. And then likewise, a lot of the graphs you've seen, you should be careful about the axes, I know Professor Warrington posted a thing recently that was just made it so clear that the people who make graphs are trying to manipulate you into listening to them. I don't mean to say that like everything's pessimistic, but a lot of them are. And a lot of the data sets you see online are not from mathematicians. So, takeaway: calculate your own percentages whenever you can. Whenever you can. How to do this? We have a formula. I'm going to write your formula down, and then we'll do some examples. Formula: F is equal to 1 plus P. I should make that plus a little more apparent. Plus P times B, where F is your final quantity. P is your percentage increase. P is negative if decrease. Okay. And B is your baseline quantity. We will, so let's go through some examples. Let's go through some examples and see how we calculate percentages. So let's do a first example. Example 1, grade calculations. I'll tell you all the examples I'm going to do. I'm going to do example 1, grade calculations. Why don't I just say examples? By the way, ours are now 33.3% all the way, which makes my life very easy now for us. Good. So we have grade calculations. Second example that we're going to do is tips at a restaurant. Third example we're going to do is sales tax. And the fourth example is the Dow Jones. Okay, and many more. Many more. Lots and lots of things. Use percentages, but you already knew that. So let's do example 1, grades. So I grade my quizzes out of 10. So say you got a 7 out of 10 on a quiz. And 42 out of 50 on exam 1. Which grade is better? Well, it's not. This is what I was saying about common denominators. It's not always that easy to see which one's better. So 7 out of 10 is pretty clearly 70%, right? We've all seen that calculation done a million times. What about 42 out of 50? How do we figure that one out? Well, in my head, the easiest way to do that is to multiply 50 by 2, you get 100, and multiply 42 by 2, and you get 84. So we could do it two ways, though. We could do that, or we could simply divide 42 by 50 on a calculator. So 7 out of 10 is equal to 0.7. And so to turn that into a percent, we're going to multiply. What does 0.7 become? It goes to 70%. Okay. And 42 out of 50. Well, the first method, as I said, is we can multiply by 2 over 2. And we get 84 out of 100, which is 0.84. And that gives us 84%. Notice that this step is not necessary here. Once we get them out of 100, I could have said 7 out of 10 times 10 over 10 is 70 out of 100. And then you literally just take the 70 and that becomes your percentage. And here you literally just take the 84 over 100, the numerator of your fraction over 100, and that becomes your percentage. Okay. So you scored better on exam 1. Good for you. Okay. Sometimes these can be a little more funny. Sometimes we have like fractional percentages or all kinds of other things, but for now we won't talk about that. Maybe I'll do just a quick example. If a bad teacher, I say bad because we want the whole idea of choosing a number of points to grade out of is not to give fractional points. But if a bad teacher gave you a 49.2 out of 60 point grade, what did you get? I would, if in this case, I would just use a calculator. I would just use a calculator So calculate 49.2 divided by 60, which is, let me go to my calculator. 49.2 divided by 60. 0.82. And so, multiply by 100. To get 82%. Good. Let's move on. Example 2. Well, actually, why don't I make a little note so this illustrates how we go from decimals to percentages. So if you want decimal to percent, you want to multiply. Why don't I put this in a different color here? Multiply by 100. And if you wanted to do backwards, go from percent to a decimal, we're going to divide by 100. These should all be very familiar things to you. So why don't we, and another thing to do, to be careful of, another caution. I'm stealing this. I didn't come up with this idea. I like this caution sign. Caution. Very small percentages / decimals can be tricky. So for instance, if I asked you what's 0.035% as a decimal, or yes, as a decimal, because notice that because we have this percent sign, even though this is a decimal right here, this is still a percentage. So as soon as you see the percent sign, you know it's not just a normal number, it's a percentage. And if you want to turn it back into a decimal, well, you're going to divide by 100. Divide by 100. Because we like base 10, we write our decimals in base 10, we do percentages in base 10, that is to say powers of 10. And so because of that, we can simply just move our decimal point over 2 places for the 2 zeros in 100. I hope you all remember that trick from elementary school, and we'll get 0.00035. That's a trick that will come back. Divide by 100, move, so I'll say i.e. move decimal point to the left 2 places to get so 0.035% is equal to 0.00035. Notice we just moved the decimal point to the left 2 and added zeros where they needed to be. So that's a tricky one too. And 1/5 of a percent. So you can also have fractions of a percent, but you might want to turn those into decimals because we like base 10. So that's 0.2%, which is actually 0.002. Okay. So that goes to 0.002, and this goes to 0.00035. Okay. Let's do some tip calculations. So example 2, at a restaurant with your friend, the bill comes to $59. What was the quantity that I said? The bill came to 56.80, I think, is actually 56.80. Okay, so because the service was good, you want to tip 3/20 of the total. So the first question, so how much to tip? Luckily, this is a little bit weird because most people already think about tips in terms of percentages. But let's do it out. So 3/20, how are we going to turn that into a decimal? Why don't we multiply by 5/5? And we'll get 15/100. Okay. And so now we know, because we have 15 per 100, we know that the numerator 15 is our percentage. Equals 15%. Okay. Well, how do we figure out how much to tip? Well, we can figure out what the tip is by simply multiplying our total bill by 15%, or multiplying tip is total times 0.15. That's the decimal form of 15%. So that should be 56.80 times 0.15, which should give us, why don't we go back to our handy calculator? 56.80 times 0.15 gives us 8.52. So that's the tip, $8.52. How could we have figured this out without a calculator? Because most of the time you're in a restaurant and you see all of your friends do their tips in their head, and you think, wow, how do they do all of that stuff in their head without a calculator? It's exactly this trick here. The way that people do their tips, because most of the time people will tip 10, 15, or 20%, and all of these things we can just use this handy little trick of moving the decimal point to the left 2 places. Okay, so what do I mean by that? A helpful trick. %10 of a quantity. So what can I say? How do I want to say? 10% of, to find 10% of a quantity. Just move the decimal point to the left 1 digit, i.e. 10% of, maybe I should say e.g. to use the correct Latin, e.g. 10% of 56.80 is 5.68. We just moved the decimal point over to the left one. Okay, so now what if I wanted to, so if I want 15%, well, if you didn't like your service very much, this is a fine way of calculating your tip. To find 15%, notice that this is 10% plus 5%. So how do we find 5%? Well, now that we've found 5% of 56.80 is half of 5.68. Okay, so put it all together, and what do you got? 1/2 times 5.68 is 2.5 plus 3.4 is 2.89, I believe. 2.89 or 2.8, sorry. 5.68 divided by 2. 5 over 2 is 2.5, and 68 over 2 is 34. So you add 0.34 to 2.5, and you just get 4 out here, and 8 here, and a 2 there. Okay, so 284 is our correct answer. Sorry, I'll remove that. So, of course, if you're not comfortable doing these kinds of things in your head, I mean, it's something to work on, 1, but 2, we all have calculators in our pockets now, so don't worry too much. You can always just go up, multiply these things together, and find the answer. But if you're sitting there under time pressure in a restaurant and the waiter's looking at you, well, what are you going to do? So then 10%, you moved the decimal point over 1. 5%, you divided that by a half. And so you'll get 15% being 10% plus 5%, which is 568 plus 284. And when you add those together, what do you get? Well, why don't I rewrite it like this? 568 plus 284 equals, we get the 2 there, bring the 1 up. That makes 7 plus 8, which is 15. So bring the 1 up there, and we get 852, exactly what we found there. So this is just a review, I guess, of how to do mental math. But don't worry, you can always use a calculator. So addition of percentages is okay. However, watch out for multiplication. I'm going to show you some things involving the multiplication. We can multiply percentages, but it often turns out different than you might have expected it to. So, let's do one more example on taxes. That's not how you spell taxes. Taxes. Say you buy a $299 iPod. I guess this book was made a little, it's okay. Buy a $299 iPod with 6.75% sales tax. How much do you spend? Well, we could find just what the tax is on the iPod. So we could do, the amount of tax is 299 times, turn the percentage into a decimal, and multiply it, right? So that's times 0.0675. And if we do that out on the calculator, I actually already did that one. We'll get 20.18. So then, if we say total amount paid is 299 for the iPod plus 2018 in tax, which makes 319.18. All right. But I want to just go back and look at this little formula. Do you remember our formula that I wrote up here? F is 1 plus PB. So what's P here? So here, F is the final amount. That's what we want to find. P is the decimal form of this percentage. So P is 0.0675. 0.0675, and B is $2.99, the baseline price that we were taking a percentage of. So then we can just use our formula. F is 1 plus PB, which is 1.0675 plus 1.0675 times 299, which gives us exactly the same thing when we enter it into our calculator here. 1.0675 times 299 gives us 319.18 when we round to the nearest penny. Good. Here we can round. We're not in apportionment world anymore. We don't have to worry too much about rounding because it's just pennies. Good. I mean, it's not always pennies when you're talking percentages, but I'm just saying, sometimes we can round. Okay. And now I want to just point out, so what if we had like a coupon code? Say you had a coupon for 5% off. Then how much would we pay? Well, so first you apply the coupon to the total price. So then the iPod costs, so, well, how are we going to take 5% away from the total cost? Well, we can multiply the total cost by 95%, or 0.95. So 0.95 times 299, which gives us 284.05, and then we'll add the tax plus tax gives you 200. So that's 0.0675 again. Actually, let's do the shortcut and do 1.0675, because 0.0675, remember, just gives us the amount of tax. You add the 1, and now you get the new quantity. You get the original quantity plus the added tax, right? So this is plus tax, 1.0675 times now our new quantity is that. So we get times 284.05. And in total, this will give us, just because I've already done the calculation, I won't write it out for you, $303.22. So now the question arises, you had a 5% coupon code, but did you actually save 5%? The answer is not quite. If you want to go back, how much was actually saved after tax? Well, we can just look at the ratio actually of our new price to the original price, and that ratio, the ratio 303.22 to the original price, 319.18. If we divide that out on the calculator, we get 0.9493, something. And so what we see is that this new price is actually like 94.9% of the original price, which means that we actually saved a little bit more than 5%. So saved a tiny bit more than 5%. Why is this? Well, because we took sales tax on a smaller price, then we added less sales tax, and so in turn you got the 5% off plus the little discount for having less sales tax. The 5% off plus a little less tax. And I think I might just let you go and read the Dow Jones one in the book. Briefly. Yeah, briefly. Let's do it. Dow Jones. This is a thing that I don't understand that much. I maybe should, but anyway. These big numbers that they use, they don't mean that much to me. So if you want them to mean something to you, you might want to turn these big numbers that they talk about into percentages. So say day one, the Dow closed at 17,975. The Dow closes at 17,975.84. Remember, and like I say, I don't know what this means, but some of you economics people might, or business people. Day two. The Dow, the Dow, the Dow Jones Industrial Average closes at 18,191.55. Well, so it would be clear to most people that the Dow has risen. That our stock market is doing better than it was before. But by how much? So how much of a difference is this? Well, if we want to know how much of a difference it is, we can just find the actual difference. So 18,191.55 minus 17,975.84 is equal to 215.71. So that's the difference in points. But then what do those points mean as a percentage? Well, we have to look at the baseline. Remember, we are taking a percentage of the baseline quantity, not the new quantity. So, as a percentage, the Dow rose not 215 points, but 215.71 out of the original baseline quantity, 17,975, which is precisely 0.85. That's so funny. 0.84. Good. So that's approximately 0.012, which goes to what? When we move the decimal point to the right, that is going from decimal to percentage, we multiply. So we move the decimal to the right. So that's going to go to 1.2%. Okay. So as the percentage, the Dow rose 1.2%. And if we wanted to, well, yeah, there are many. I just want to point out again that there are many methods for figuring these things out, and you really just have to decide what one works best for you. You certainly don't have to go back and use this formula every time. This formula is helpful for some people, but maybe it's not helpful for you. So there's a bit of intuition that you need to use with these percentage things. And sometimes your intuition will fail you. So now I want to talk about some traps. Sometimes your intuition will fail you. That shouldn't. I'm not trying to be negative or anything, but so common traps. So one more time, caution ahead. Common traps. 1. Combining percentages. So if you get a 10% raise at your job this year, and then next year you get a 15% raise, lots of people would be tempted to just add those numbers together and say, I got a 25% raise. That's not true. In fact, you've done better than a 25% raise. So if you get a 10% raise this year, or why don't I say got? If you got a 10% raise last year, and receive another 15% raise this year, you have not gotten a 25% raise in total. Instead of adding these percentages together, we're supposed to multiply them, and then we get something a little bit different. So your final, in fact, your final value is going to be 1.10, so that's the first raise you got, times your base. So maybe I'll do it like this. Maybe I'll write it from right to left. 1.10, that's your 10% raise, times your original base pay. And then, after that one, you got a 15% raise. So that's like multiplying it again. But what we actually get when we do this, 1.15 times 1.1, is actually 1.265 times your base pay. So, in fact, you end up with a 26.5% raise. All right. That's kind of cool. Okay. Another thing to be careful of is what 1% or 200% means. So combining. Right. Sorry. So how about another one related to stock? What if I told you that? So what if you were looking at the Dow Jones, looking at the Dow Jones yesterday? Your stock went up 25%. Today, it went down 20%. What is the total percent change? Well, you might be thinking, well, I've probably got a 5% change, and the stocks probably went up in general in my favor. If I combine, so why don't I put this in red? Might think to add 25, or subtract 20 from 25. Don't. Instead, if you want to calculate the total percent change, well, so you had a base amount of money, right? And yesterday, your stock went up 25%, so we'll multiply it by 1.25. And then today, your stock went down 20%. So that's like a negative 20% increase. So we can write that as 0.8. I hope that's clear why I can write 20% decrease as 0.8. Well, it's 0.2 less than 1. And a 1.25%, or 1.25 here refers to a 25% increase. So if you see it's above 1, it's an increase, below 1, decrease. Well, what happens when we add these things up? In fact, this is just b. And maybe fractions are an easier way to see this, because 0.8 is 4/5, and 1.25 is 5/4. So then things just cancel, and we're just left with 1. So in fact, you made no money. No money. And this is for kind of the opposite reason that you actually got a bigger raise than you thought. So here, your stock went up 25%, but that was 25% of a smaller number. And then when it dropped 20% today, that's 20% of a bigger number, which is bigger. So lots of the same things that tricked us with apportionment too. If a pair of shoes, sometimes you see 2 markdowns, is marked down 20%, then another 30%. This is not a 50% markdown. It's a trick. Don't let them trick you. How much of a markdown is this? Well, if your pair of shoes was originally B equals original price. Well, let's calculate it. So if it got marked down 20%, then that's F is so. Marked down 20%, remember we multiply by 0.80 times B. And then when it goes down another 30%, we multiply by 0.7, right? Because that's back another one. Well, now, what do we get when we multiply 0.7 and 0.8? Well, 7 times 8 is 56. So we actually are going to, this is actually 0.56 B. And so, in fact, this is only a 44% markdown or sale. Okay, so be careful there. Also, sometimes people will talk about like 200% markdown on a TV. That doesn't make sense. If somebody tells you that a price has been marked down 200%, they're confused. Because what they're actually doing is they're flipping the F and the B. That's the problem. So if a $36,000 TV is marked down to $1,200, why don't I write that more clearly? $1,200. This is not a 200% markdown, though they might try and tell you that, because 200% of 100 and although 200% of 1,200 is 2,400. In fact, if 36,000 is our base price and 12,000 is our final price, then we have 12,000 equal to 1 plus P times 3,600. So then we divide both sides by 3,600, divide by 3,600, And we get 1/3 over here equal to 1 plus p, which means that p has to be what? Negative 2/3. So p is negative 2/3. So in fact, what's negative 2/3 in a percentage? This is a 66.6% markdown. And that kind of makes sense. If you divide 3600 into thirds, you get 3 1200s. And so you take 2 of those thirds away and you get down to 1200s. So that's a 66% markdown. Okay, I want to finish this lecture up with a fun one. So this is to conclude the potato paradox. All right, so how's the potato paradox go? The potato paradox says that, so Farmer Joe exhibited here. Well, he's got a big old sack of potatoes. Okay, so in his hand, he has a big sack of potatoes. But Farmer Joe is sad. So this is 100 pounds. And Farmer Joe has 100 pounds of potatoes. As a middle schooler once explained this paradox to me, he's sad. So these are little tears coming down from his face. He's sad. Why is he sad? Well, because his potatoes have too much water in them. He is sad. His potatoes have too much water in them. His potatoes, so his potatoes are 99% water, and 1% solid potato, say. And actually he would like them to be 98% water. So his potatoes have too much water in them. Currently, in the bag, so currently they are 99% water, 1% solid potato. Joe wants 98% water, 2% solid potato. And so what's he do? So he leaves them out in the sun. Next day, the potatoes are indeed 98% water. Indeed, 98% water. But Farmer Joe is shocked. Why is he shocked? Well, he's shocked because, but the 100 pounds of potatoes is now much less. So maybe I'll finish this here, and I'll let you try and figure out how much does the bag weigh now? And I will answer that question at the beginning of the next lecture. Good.